morning. In this video, we're going to talk about proposition 1 from book 2. So this proposition declares that if we are given two finite straight lines, for example L and L prime, and we cut a straight line into multiple segments, for example A, B, C, and then the rectangle contained by these two straight lines are equal to the rectangles contained by the uncut straight line and those segments. Okay, so let's give it a proof. So sorry, first of all, if we write down the expression of this proposition, it will be L times L prime will be equal to L times A plus L times B plus L times C. So this is the proposition we are going to prove. First of all, please recall proposition 11 from book 1. We are able to construct perpendicular lines with a given point and a given straight line. So let's construct this straight line that is perpendicular to L prime, and then we can use proposition 3 from book 1 to cut off a straight line here that is equal to a given straight line L. So they are equal, okay? And the next step is consider proposition 31 from book 1. We are able to construct a straight line that is parallel to a given straight line through a specific point. So at this time, let us construct this straight line through the point here that is parallel to L prime, okay? And then let us use this proposition again to construct three straight lines respectively, here, here, and here, which are at those extremities of A, B, C respectively. Okay, so we constructed these three parallel lines, which is parallel to the left one. Okay, great. So now we know that these three multilaterals must be parallelograms, right? Because both sides, the opposite sides are parallel to each other, right? And please consider the definition 1 from book 2. If we are given a parallelogram contains two straight lines that contains a right angle, then it is a so-called rectangle, okay? So this is a rectangle, right? Let's mark it as R1. Also, this is another rectangle, R2 with similar proofs, and R3. We can prove there are three rectangles because they contains one right angle and they are parallelogram, okay? And if we apply proposition 34, we know that opposite sides of parallelograms are equal. So they are equal, right? And in these parallelograms, they are equal. And in this parallelogram, they are equal, okay? So we have proved they are three rectangles, and we can also prove the whole part. It contains a right angle and it is parallelogram because we construct it like that, okay? So this is another rectangle. Let's call it R. Is the whole part, okay? So simply we can conclude that from this diagram we know that R1 equals A times L, which is the straight line by the segment, okay? R2 equals B times L. R3 equals C times L, okay? And the whole rectangle equals L prime by L, correct? And if we have a look at this image, we'll know that the sum of these three rectangles will be equal to the whole rectangle, which means equals to, and this proves our proposition, okay? to be more concise, we can express this proposition in a algebra form. That will be, for example, we have a sum of n items, and if we multiply a constant by that, it will be equal to the sum of the constant, or let's say the factor, times every segment or every item here. Okay, so this is a concise and let's say algebra expression. Okay, and that's the end of this video. In the next one we are going to discuss proposition 2 from book 2. Thanks for watching. Have a good day.